Students, have you ever noticed that you have a cold drink bottle and you just open this bottle and identified the gas and the bubbles coming out of it? Have you seen that? And do you know why it's a happen? And sometimes you go to the mountain regions where you can identify that like vomiting sensation, nausea, giddiness, and deep sea divers, when they go down of the water and come quickly, they feel like some painful situation and they won't feel comfortable. Behind all these real life examples, there is a most important concept, that is Henry's law. In today's session, your Kumali ma'am is going to teach you Henry's law and most important applications behind Henry's law and how to solve numericals from Henry's law. Are you ready? Open your book and get started. Let's see the definition of Henry's law. What it states is, at a constant temperature, pressure is directly proportional to the solubility. More is the pressure you apply, more is the solubility. What is that? More is the pressure we apply, more is the solubility. Henry's law is for the solubility of gases in the liquids. It explains the solubility of the gases in the liquids. Then, for example, if you have one bottle like this, any bottle which you are having, in this some sugar solution is present and you kept the gas and sealed it with a high pressure. So, whenever you have a bottle and you are sealing that sugar solution, some solution is there and you are putting a gas and sealing it with a high pressure. So, more is the pressure you apply, more amount of gas is soluble in the liquid. So, based on that, the Henry formula is P is proportional to the solubility. Here what I am telling you, in this container, okay, this is a total moles. Total moles, let's say number of moles of gas plus number of moles of some solvent or water or sugar solution is present, let's say, okay. In that, how many moles of gas is dissolved? More pressure you put, more moles of gas is dissolved. So, how many moles of gas is dissolved out of the total moles? So, that is called as mole fraction. What do you mean by mole fraction of a gas? Number of moles of gas that is dissolved in total moles of a solution, total moles, either sugar solution or a gas, whatever the total moles, in that how much gas dissolved, that is called as mole fraction. So, in place of solubility, I want to keep that pressure of the gas. More pressure you apply, more gas will be dissolved, that is proportional to the solubility of the gas in that particular solution, that is called mole fraction of the gas. Then remove the proportionality, put a constant. This is based on Henry, so we gave it as in Henry's constant KH, which into mole fraction of gas. Can you repeat the formula, children? Pressure of gas is equal to KH, Henry's constant, into mole fraction of gas, that is X gas. Done? Is it clear? Now, what I am going to do is, this formula, if you observe carefully, pressure of gas is equal to KH into mole fraction of gas. Now, if I increase the pressure, what happens? If I increase the pressure, solubility increases. Solubility increases, fine. And this solubility of gas in a liquid is an exothermic process. What is this process? It is an exothermic process. Means it releases energy outside when this gas dissolves in a liquid. When it is an exothermic reaction, if you increase the temperature, what happens to the solubility? Whatever the gas dissolve, it comes out. Solubility decreases. Solubility decreases. Solubility, if you increase the temperature, solubility of the gas decreases. That is the reason, no, aquatic animals, the animals which lives under the water, under hot conditions, they die because the dissolved gases come out of that. Oxygen present in the water come out of it, and the animals don't get sufficient oxygen, they die. Is it clear? Now here I want to say that KH is equal to pressure of the gas divided by mole fraction of the gas. So I want to say that KH and mole fraction or solubility inversely proportional is, I can write 1 by x of gas, I can write, or inversely proportional. KH is inversely proportional to the solubility. So temperature also inversely proportional to the solubility. KH also inversely proportional to the solubility. Based on this, we can write that temperature increases, KH increases, solubility decreases. Most important, from this itself you can directly solve the question. Higher temperature, higher Henry's constant, lower will be the solubility. Is that clear, students? Now, we have a formula. Pressure of a gas is equal to KH into mole fraction of a gas. From this, I can write it as Y is equal to mx, and there is no C here. See, here no intercept. Intercept is here, nothing is there. Intercept, no intercept in this equation. It is like Y is equal to mx. On Y axis, you take pressure of the gas. On x axis, what you can take? Mole fraction of the gas. And there is no intercept in this equation, which means that the line passes through origin, and the slope is m here. In Y is equal to mx plus c, what is m? M is the slope. So slope is what, if you relate, that is KH. This is the graph for Henry's law. What are the favorable conditions for Henry's law? I mean solubility, temperature should be low and pressure should be high. These are the favorable conditions. Okay. Now, let's see the three most important applications of Henry's law in this cold drink bottle. If you see that more pressure you apply, more gas will be soluble. If you remove this cap, what will happen? Whatever the gas soluble, it is coming out of this. Correct? It is coming out of this high. Okay. Then what is that? Pressure increases, solubility also increases. Okay, done. Next one. If you see the scuba divers, this scuba divers, just a minute, students. My keyboard is filled with cold drink. Okay. Scuba divers, what happens here? Scuba divers, these are the people, they go down of the water to study about the animals, plants and all. Okay, so when these scuba divers go down of the water where the pressure is more, when pressure is more amount of nitrogen will be dissolved in their blood. Whenever more nitrogen, solubility, pressure is more, solubility is high, right? So more amount of gases dissolved in their blood. When these people come quickly on the top of this water and all, low pressure, when low pressure, the dissolved nitrogen, it comes out. When it is coming out, it creates bubbles in the blood. That bubbles create very painful situation. We call it as the disease, that problem we call it as a bends. In order to avoid this problem, they carry these oxygen cylinders. This cylinders contains helium, this cylinders contains nitrogen, and this cylinders contains oxygen. How much percentage of helium do you know? 11% helium, 11. See helium, how we write? H we write, right? See, like this one line, see 1 1, like this if we write helium. So in order to remember, just it is 11.7. Simple, I am telling you. 1 1, like this we write na, helium 11%, simply 1 1 11. Nitrogen 56%. How to remember is nitrogen atomic number is 5. So first number is 5. Remember that. Oxygen molar mass is 32, so its percent is 30. Just mnemonic to remember that. Repeat, helium 11.7%, nitrogen 56%, oxygen is 32%. This combination of the oxygen cylinders they carry when they go down of the water to avoid this problem. And whenever sometimes if you climb the mountain regions, what happens there, less pressure. When less pressure, solubility also less according to Henry's law. When solubility is less, then what will happen? Less soluble means we feel like giddiness, nausea, vomiting sensation we feel. That problem is called anoxia. These all are the applications of what? Henry's law. Now see this question. Mole fraction of a gas in water is given as 2 into 10 power of 5. Mole fraction is given 2 into 10 power of minus 5. Partial pressure of the gas is given as 1 bar. Can you find KH? How to find? Pressure of gas is equal to mole fraction into KH into mole fraction of gas. Then KH they are asking us to find. Pressure is 1 bar. Mole fraction of gas is 2 into 10 power of minus 5. 1 by 2 is 0.5 into 10 power of minus 5. 0.5 we can write it as 5 by 10. Then it will be, how much students? It is 10 power of, 5 by 10. Then it is 5 into 10 to the power of 4. Am I right? 5 into 10 power of 4. Okay. Mole fraction KH is equals to 1 bar, 2 into, then if it is 0.5, 10 power of 5, then 5 by 10 into 10 power of 5. Okay, 4. Yes, is it clear? Next question. The Henry's law constant KH values for the 3 gases A, B and C are given. The order of solubility they were asking. So A gas how much? 145 bar is given. B gas is given 2 into 10 to the power of minus 5 bar. Gas C is given 35 kilobar. Kilobar means 1 kilo means 1000 bars into 10 power of 3 bars. Now more is the KH value. Which is more? This is more. KH value is more, then what happens to the solubility? Least. C is least soluble. C is least soluble. So this option A or C. Now in this 3 which is having a lower KH value, B is having low KH value. Low KH value, high solubility. Low KH value, high solubility. So A, B, C which is more soluble, B is more soluble. So option A is the correct answer. Now see the next question. This is one of the question which is previous is asked in a NEET around 2024. This is the JEE question. Let us see the Henry's law constant for N2 in water is KH value is given. What is given? KH value is given 10 to the power of 5 atm. Mole fraction is given 0.8. Number of moles of nitrogen dissolved they are asking in 10 moles of water. See students here, pressure of gas is equal to what you can find? KH into mole fraction of gas. This is gas. Yeah, they have given more. This is mole fraction of gas in the liquid, which this formula. But they have given mole fraction of nitrogen in air. You should not substitute here. Formula to calculate mole fraction in the air. What is the formula? Can you tell me? P total. Pi is equal to P total into Xi. This is the formula to calculate mole fraction of the gas in the, mole fraction of that particular gas in air. This is mole fraction of the gas in the liquid formula, that is. So P total pressure is given 5 atm. Mole fraction Xi is given as 0.8. then it is 4 atm, units are atm. Now this is the pressure of PI, means pressure of gas. Okay, this pressure of gas you substitute here 4, and Henry's constant is given 1 into 10 to the power of 5 into mole fraction of gas. Mole fraction of gas means number of moles of gas by number of moles of gas plus total number of moles. So you find the mole fraction of gas, how much you will get? Number of moles of gas divided by 2. See this one, whenever you do this numerical, this is negligible when compared to total number of moles. Why? Because both if you have to find means you cannot find. Then 10 power of 5 go, that said 4 divided by 10 power of 5, which means that 4 into 10 to the power of minus 5. Okay, number of moles, how much is given in the water? 10 moles of water. Then what we will be getting? Number of moles of gas is equal to 4 into 10 power of minus 5. This number of moles of water is 10. If this side, if it comes 10, right? Here it is dividing, it comes multiplication. Then it will be 4 into 10 power of minus 4 moles. So which is the correct option? Option B is the correct answer. I hope you like this video. I'll give you 2 questions. Test yourself. Take a screenshot of this or pause this video and try these 2 questions and let me know your answer in comment section. If you want to learn entire chemistry from basics to depth in such a simple manner, you can attend my online classes. For more details, click on the description. If you want to learn, through my YouTube videos, let me know which topic you are feeling difficulty in comment section. I will make in my next video. Thank you so much for watching this video. See you again in next video. See you soon, students.